Hello, this is P.V. Sudarshan from the Department of Chemistry, St. Joseph Pre-University College, Bangalore. In today's session, I will be discussing on the topics metallurgy and solid state chemistry. Our first question, which method of concentration depends on the difference in specific gravity of ore and gangue? In metallurgy, there are three stages. The first step is concentration of the ore, meaning removal of impurities. In the language of chemistry, impurities means gangue. The second step is reduction of the metal oxide. And in the third step, we have refining of the metal. The question that I have asked here is on concentration of the ore. There are various methodologies of concentration depending upon the nature of the ore and gangue. If the impurities are lighter in nature, they are concentrated by hydraulic washing. It is also known as lavigation. If the impurities are magnetic in nature, they are concentrated by magnetic separation method. If the ore contains sulfur, meaning sulfide ores are concentrated by froth flotation process. And then if the ore is soluble in any suitable solvent, it is concentrated by chemical method, which is also known as leaching. Now, after listening to my commentary, you should be able to answer this question. I am reading the question again for you. Which method of concentration depends on the difference in specific gravity of ore and gangue? The ore and gangue are differentiated depending upon their densities, that is here specific gravity. The best method of concentration is by hydraulic washing. Therefore, the correct answer is option A, hydraulic washing. Our next question, which of the following metal oxide undergoes reduction with aluminium? Dear students, I hope you are aware. I just discussed with you the three methods that are involved in metallurgical process. Number one is concentration of the ore. Number two is reduction of the metal oxide. And number three, refining of metal. In this, metal oxides can undergo reduction depending upon the nature of the metal oxide and the reducing agent that I happen to choose. Metal oxides such as iron and zinc are best reduced using coke or carbon monoxide, while special metal oxides such as aluminium and chromium are reduced using aluminium as the reducing agent. This is a very important point and an underlining point. If aluminium is used as a reducing agent, then it is known as aluminothermite process. In the aluminothermite process, aluminium is specifically used as a reducing agent in the reduction of oxides of chromium and manganese. Now my question, which of the following metal oxide undergoes reduction with aluminium? I just specified that aluminium acts as a reducing agent for the reduction of oxides of chromium and manganese. Therefore, in the options that I have A, B, C and D, option C, aluminium can reduce oxides of chromium. Option C is the right answer. Our next question. Which is the hottest zone in the blast furnace? You should be aware that blast furnace is used in the extraction of iron. Blast furnace, the name itself says, furnace is that which can withstand very high temperature. In the extraction of iron in the blast furnace, there are various zones. One is zone of combustion, zone of reduction, zone of slag formation, and zone of fusion. Now, which is the hottest part under this? I would preferably say zone of combustion is the hottest zone in the blast furnace. It requires a temperature of around 2200 Kelvin. Then what about zone of reduction? Zone of reduction approximately takes place in the range 400 to 800 Kelvin. And finally, zone of slag formation, it is approximately in the range 1200 Kelvin. Therefore, the hottest part or the hottest zone in the blast furnace is zone of combustion. Therefore, option B is the right answer. Our next question. In the process of smelting, which of the following options are right? So, before understanding what is smelting, few more terminologies such that you get a relative relation between smelting and the other terms which are very common. You would have heard about the term called roasting, calcination and smelting. Now you look in the classical difference between all of these. Roasting is a process of heating the ore to a high temperature in the presence of air or oxygen. Similarly, calcination is a process of heating the ore to a high temperature. Calcination is a process of heating the ore to a high temperature in the absence of air or oxygen. Smelting is the process of heating the ore to a high temperature again. Then if you happen to look in all the three cases I said, ore is heated to a high temperature in the presence or in the absence. Then what is that differentiate these three? Very important term. When ore is heated to a high temperature in the presence of air or oxygen, just below its melting point, I call it as roasting. When ore is heated to a high temperature in the absence of air or oxygen, just below its melting point, then I call it as calcination. When ore is heated to a high temperature beyond its melting point, then I call it as smelting. Therefore, hope you would have understood this term. When ore is heated to a very high temperature beyond its melting point, then I call it as smelting. Hope you would have understood the terminologies now. Looking into the options now, option A, ore is heated in absence of air, it is calcination. Ore is concentrated. This is the first step in metallurgy for removal of impurities. Ore is heated in presence of air. This is roasting. And finally, ore is melted. This is most appropriate for smelting. Therefore, the right option is option D. Our next question. In pig iron, the maximum impurity is option A phosphorus, option B manganese, option C carbon, option D silicon. There are minute impurities plentiful, but that which is to a maximum extent is carbon. It is to an extent of 2.5 to 4%. Therefore, in this, the right option is option C, carbon. Few more points to understand. There are three varieties of iron. One we call it as pig iron, other one is wrought iron, the other one is steel. Pig iron is that which contains maximum percentage of carbon, that is to an extent of 2.5 to 4%. Wrought iron is that which contains nil or minimum percentage, that is approximately around 0.1 to 0.2% of carbon. It is also labeled as purest form of iron. Wrought iron is the purest form of iron. Steel happens to be intermediate between wrought iron and pig iron. It is to an extent of 0.2 to 1% of carbon is present in it. Hope you have understood. Three varieties of iron. Pig iron, maximum percentage of carbon to an extent of 4%. Steel, intermediate between pig iron and wrought iron. Wrought iron is the purest form of iron. Dear students, it is necessary that we try to prepare or we learn much about the alloys, their composition. This would be a handy exercise for you to attempt plentiful question in the CET examinations. Now our question. An alloy which does not contain copper is option A solder, option B bronze, option C brass and option D bell metal. In this, the first option solder is an alloy of lead and tin. It does not contain copper. Obviously, this is not an alloy containing copper. Option B bronze. Bronze is an alloy of copper and tin. Brass. Brass is an alloy of copper and zinc. Bell metal is an alloy of copper and tin. One of the distinguishing feature between bronze and bell metal is both contain copper and tin, but in bell metal the proportion of tin is greater when compared to that which is existing in bronze. Therefore, option B bronze, option C brass and option D bell metal all contain copper, but option A solder does not contain copper. Therefore, an alloy which does not contain copper is solder. Option A is the right answer. Our next question. In the extraction of nickel by Mons process, the metal is obtained by Now what is Mons process? Mons process is the final stage of getting the metal in the purest form. Nickel is refined by Mons process. If nickel is refined by Mons process, how does it do so? By passing carbon monoxide through nickel, I get a complex tetracarbonyl nickelate, that is NiCO4, which on further decomposition gives me purified nickel or pure nickel. From this I understand, when carbon monoxide is passed through nickel, I get NiCO4 complex, which on thermal decomposition gives me pure nickel. Therefore, looking into the options, electrochemical reduction, option A, option B, thermal decomposition, option C, chemical reduction by aluminium, option D, reduction by carbon, I suppose the most appropriate answer for this is option B, thermal decomposition. Option B is the right answer. And then few more points about the options. Reduction by carbon that I have in option D is the second step in metallurgy. Reduction of metal oxides such as zinc oxide and iron oxide can be reduced using carbon as a reducing agent. Option C, chemical reduction by aluminium. This is known as leaching. Leaching is a chemical method in which the bauxite ore of aluminium is treated with sodium hydroxide to get sodium aluminate. Hope you understood these two concepts. Let's now understand few finer points in Ellinghams diagram. What is Ellinghams diagram? Ellinghams diagram is a graph of standard free energy change versus temperature. Ellinghams diagram is used to select, elect and predict the best and the most suitable reducing agent for the reduction of oxides, sulfides and halides. Therefore, the question that I have here, the curves in Ellingham diagram represent option A sulfide, option B oxides, option C halides, option D all of these. Option D, Ellingham's diagram can represent sulfides, halides and oxides. Few more points. In Ellingham's diagram, we have a graph of standard free energy change versus temperature. More negative the delta G naught value, more powerful reducing agent it can act as. Wherever there is a change in the slope of the line, it indicates that at that particular temperature, it undergoes phase transformation. If delta G naught value is equal to 0, it cannot act as a reducing agent. For example, in Ellingham's diagram, carbon dioxide, the line is parallel to x-axis, it cannot act as a reducing agent. While there are few which have got positive delta G naught value, they can never act as a reducing agent, they are unstable in nature. Hope you understood these points. Remember this, it will definitely help you in preparing well. Which metal is refined by poling? Now, what is the meaning of refine? Refining is a final stage in metallurgy to get the metal in 100% pure state. And when it is said that refined by poling, Poling is a method of refining in which the metal oxide itself acts as an impurity. For example, in the options that I have here, option A silver, option B sodium, option C blister copper, and option D zinc. I would say the right answer in this is option C blister copper, because it contains Cu2O, its own oxide, as an impurity. Therefore, option C is the right answer. Few more inputs about blister copper. Blister copper is 98 to 99% copper. It is obtained after concentration of the ore by froth flotation, and the ore, when it is roasted, the final stage in the roasting process is blister copper. Our next question. On heating mixture of Cu2O and Cu2S, the product formed is. This is an equation in the extraction of copper. In the extraction of copper, the first stage is concentration by froth flotation process. Because I mentioned it as froth flotation process, understood that there is sulfur present in the ore. Therefore, I take chalcopyrite, which is also read as copper pyrite. CuFeS2 undergoes concentration to form concentrated ore. Now, the concentrated ore, that is CuFeS2, undergoes roasting. I will just show you the equations how the final process will take place. I have the concentrated ore CuFeS2 undergoes roasting to form what is known as Cu2S, along with that Fes, along with that I also get sulfur dioxide. I understand that it is a process of roasting because sulfide ores are roasted. By all probability in the equation, sulfur dioxide is liberated. My main intention is to get copper. Therefore, I have to get this Fes reduced, converted into another form. I have Fes. In the process, it is further undergoing roasting to form what is known as FeO, liberating again sulfur dioxide gas. I understand that FeO is the impurity. To remove the impurity, I add a minute quantity of flux. I hope you are aware. Flux is that which is used to remove the impurity. SiO2 acts as the flux to form FeSiO3 to be the slag. Therefore, it is a recap of what you have done earlier. Flux combines with gangue to form the slag. Now, I have successfully eliminated Fes. Now, I have Cu2S, which is further undergoing roasting to form Cu2O, again liberating sulfur dioxide gas. I have not balanced the equation. I hope you will understand how to do it up. Now, if I happen to stop the supply of oxygen, by all probability, the product that is being formed will react with that which is remaining. Now, the product that is being formed will react with that which is remaining. Therefore, Cu2S will react with Cu2O to form copper, liberating again sulfur dioxide. The copper that is obtained by this method is known as blister copper. Now, by looking into the options here, A, B, C and D, I have in option D, Cu plus SO2 is the most probable product. Therefore, option D is the right answer.